Welcome everyone to today's Synergist webinar, 7 Steps to Improve Your Industrial Hygiene Program. I'm Kay Bechtold, Managing Editor of the Synergist, the magazine of AIHA. I'd like to thank all of our attendees and especially Velocity EHS for sponsoring today's webinar. Our speaker today is Dave Reese, a board-certified industrial hygienist and safety professional with over 30 years of EHS experience. Dave started his career as a senior industrial hygienist for Exxon before moving to Oracle to help build their EHS application. In 2001, Dave acquired the application and formed Pyramid to bring it to the broader marketplace, expanding its use to over 60 countries. In 2019, Velocity EHS acquired Pyramid and brought Dave in to oversee the industrial hygiene solution. He is now the principal solution strategist of industrial hygiene for Velocity EHS. And now I'll turn the presentation over to Dave.
Thank you, Kay. Let me share my screen. All righty. Okay, well, thank you everyone for your time. I know we're all very busy at work, and we've all have probably way too many Teams meetings and other meetings, so I appreciate your effort at coming in and having one more webinar and one more Teams meeting, one more virtual meeting thrown into your day, because we're having a lot of these days. So the scope of today's webinar is really a way to think of a lot of things that we do in industrial hygiene and try to make it into a process, a repeatable process where we can streamline, simplify, and add more value with our industrial hygiene program to our organizations. And let me just move forward here. So the goals of today, the 3 main topics that we'll cover is to understand that methodology to make life just a lot simpler for all of us, and how to move from a reactive compliance-based program into more of a proactive risk-based IH program. And third is how to better communicate with workers and management. We all do a great job of communicating, or I should say documenting what we do, and we do a lot of stats analysis, and there's a lot of really powerful IH professionals out here, but that doesn't have anything to do with communication. So I'm going to spend some time at the end really focusing on communicating and adding value to our stakeholders. So some of the current trends that we're seeing in our industry, our profession, is that there's a lot of people leaving it. Baby boomers are retiring. Some IH positions are not being refilled, so we're being asked to do more with less. IH is being absorbed by other EHS professionals. There's consultants, there's EHS generalists, there's safety, there's a bunch of other EHS generalists, I call them in general, that are managing our IH programs, which has led to more of a reactive and compliance-based program for a lot of companies out there. One quick example of this, years ago, a company came to us and said, hey, we really need to have your industrial hygiene software so we can store all of our samples. I'm like, well, okay, great. What is it that what's the goal that you're looking to accomplish? And they said, well, we just need to store all the samples so we can have one place to store it all. I'm like, okay, well, why would, so I kept asking the 5 whys, of getting to the root cause of what their ultimate goal was. And what I found out was that there was a class action lawsuit that's dealt with silica, and their ultimate goal was just to collect 9,000 samples over the course of 3 years and have enough data to say we've got enough data and we don't need the class action lawsuit was greatly reduced because they said they were going to beef up their IH program, and they thought that meant having an IH database. And when I questioned it, I fought a really uphill battle, and they decided what they wanted to do, and they went forward, collected their 9,000 some odd samples, and at the end of 3 years, they laid off the entire industrial hygiene workforce. So did we really get much accomplished? And I did, that's an extreme example, but there was no value to that company for industrial hygiene other than collecting data to cover their butts and get them out of some litigation. So really, we need to focus in on our profession and how do we change that mindset? Not that that's all that common, uh, but it is out there. I've seen it more than once. So with those challenges comes a lot of good opportunities. It really is a good time to rethink how IH programs are managed, um, and looking at other risk-based processes. How do we incorporate industrial hygiene into those similar processes, um, and ultimately reduce the dependencies on just sampling and analysis? We're just going to collect a bunch of samples, store it in the database. We can run all the stats, imaginable, and look at all these great numbers, and we're not adding a lot of value to the business by doing that. And then the last piece is great opportunity for us to really finally cross that threshold and have an improved communications, um, with both workers and management, so we can show the value of what industrial hygiene is and what we bring to the organization. So as a result of these opportunities, we will begin to focus on more value-added activities, which brings us to our IH program cycle, and really to help us get organized and move towards a more process-based system, we put together this IH program cycle. Some of these might be very similar to you. Some of these might be new for some of you. We're going to cover some of these in greater depths, some of them at very high level, some of those in deep dives, but we wanted to make sure we cover all 7. Briefly, number 1 is basically doing your site characterization or developing your similar exposure groups. We'll cover that briefly. Qualitative exposure assessments or risk assessments, sampling plans. So what are you going to sample? Why are you going to sample it? And measuring your tracking, where you're at versus the actual plan for the year. Lab analysis. There's a lot of things we can do to streamline and make our life a lot easier when you're working with laboratories. We'll cover that. Data analysis. I could spend hours or a whole day on just data analysis. What people think of data analysis versus how we need to really think about data analysis might be a big shift in your thinking. Medical surveillance has got to be covered. Obviously, that's one of the critical roles that most of us play, so we'll cover that. And then the 7th step is obviously the most important of all, is we do all this great work. If nobody knows what we're doing, we don't effectively communicate that. We're going to be where we're at today. So let's cover briefly similar exposure groups, SEGs, SEGs. Essentially what this is, and I'll use this example throughout the presentation, of a refinery. So I've got all these workers up top. Do I need to go out and measure each and every one of those? The obvious answer is no. We put them into groups of exposures or similar exposure groups. And examples of those are my little blue guys and gals are, maintenance technicians in the maintenance department. The orange, I guess it is, they're operators at the reformer unit. And the gold, I guess, is operators at a, same job. They're operators, but now they're at the cooker unit versus the reformer unit. So these exposure profiles are different, and I could put them into similar exposure groups, or SEGs. Okay, so how do we go about developing SEGs? Number 1, you got to get out there. You leave your desk, you got to get out there and observe all the workers in your site. There might be tons of paper reports out there, studies and things like that. That's great, but I feel you learn the most when you get out there and you start talking to workers and observing the workforce. Identify what common jobs or roles can we put workers into separate groups. For instance, I don't care if you're an operator 1, operator 2, operator 3. I can group them all into this term called operator. So your pay grade from HR, I don't care. You're a maintenance technician, you're an operator, you're an electrician, you're a pipe fitter. And then what tasks are they performing? Is it their common routine full shift exposures, or are they doing specific tasks where I might want to measure or do a qualitative exposure assessment, do any risk assessment on what their exposures are during welding, sampling, opening vessels, whatever those individual tasks might be, maintenance activities, turnaround activities. Um, and then next is, what equipment do they work with that could affect their level of exposure? A couple simple examples. One is a paint booth. I have 2 paint booths. One is a really old one. The fan hasn't worked in 5 years. I've got an inch thick of paint on it. The vapors are everywhere. Versus a new paint booth, the fan actually works. Your capture velocity is good. It's pulling the vapors away from the worker. It's the same person doing the same job, could be in the same area, but they're working with 2 different pieces of equipment. Their exposure profiles are going to be separate. So I would separate those 2 people working with those 2 pieces of equipment as separate exposure groups. And then once you identify those groups, then you want to just list all the stressors that they could be exposed to during full shift or during specific tasks, noise, benzene, asbestos, lead, whatever the case might be. And at the end of the day, my deliverable is a table. And so I've got my segs are identified by location, job, and task. If I had equipment, I would list the equipment in there. And I don't worry about individual stressors. I just list every possible stressor that could be of significance that I need to assess. Okay. Okay, so that was kind of a brief overview for most of you. Jumping forward into step 2, which is our qualitative exposure assessment piece. This is where I like to say, let's jump in the bandwagon. So safety is, they've got it figured out. They've got very simple communications. They are in with the top management. They know how to sell safety. If your safety group or your quality group, if they've got a risk matrix, green, yellow, red, red bad, green good. I mean, it's pretty simple. If they've got something that says we got a 4x4 matrix and we're looking at severity and likelihood, you look at that and say, hey, let's apply that to industrial hygiene. So instead of severity and likelihood, I'm going to use the AIHA exposure assessment strategy in most of my discussions today. But so let's look at health effect rating versus exposure rating, and let's match up exactly what the matrix is that safety uses or quality uses. So if they use a 4x4 with 3 colors, I'm going to match up exactly with that. If they've got a 5x5, a 6x8, whatever, in 4 different colors or 8 different colors, I'm going to adapt my industrial hygiene to what that is. Because if I show something different, you really disconnect that connection, that level of understanding. That this is something that's critical for us to understand. If safety's doing it right, jump on the bandwagon, look at it, and follow what works. Okay. So to develop your risk matrix, we really need to define what the exposure ratings and the health effect ratings are. So we'll start off with the exposure ratings, again, right out of AIHA Exposure Assessment Strategy book. If we have no data, then we have to rely on professional judgment of what the quote unquote typical risk is. We'll dive into that more in a second. The rating table up in the upper right-hand corner in blue is a standard way that a lot of our customers, a lot of IH professionals do their exposure rating as a percent of OEL. So 1, really low, less than 10%, 4, really high, your typical exposure risk is greater than 100% of the OEL. So that's if you don't have any data. If you have data, excuse me, some data available, hey, that's fantastic, but which statistic are you going to use? So there's tools out there like the IH stat tool, which is a second screenshot I got down there. a lot going on, lots of stats. It's great. Guys, we just love our stats, right? But we have to decide, number one, are we only looking at normal or log normal distributions, or what is the distribution for my seg? And then which stat are we going to use? Most commonly people use, I would say geometric standard deviation. Probably the highest one is 95th percentile. If you're working with a high potency industry, like you're in pharma, you're probably going to deal with a 95 point estimate, or maybe even the 95th percentile. Whatever it is that you pick which one it is and document it. Decide which one to use and document it. If you're dealing with dust, it's not as critical if it's just nuisance dust and noise and things like that. But if it's something that's, like we said, a high potency material, you want to get a little bit more granular. Okay, next is the health effect rating. In an ideal world, you've got a team of toxicologists to go to. One of my previous jobs, we had some toxicologists, and it was great. Not many people have toxicologists on staff, so then you need to look at reference material. GHS is a great resource. They've got health categories. Unfortunately, that's not a straight number, but you can look at the health categories, define your strategy, and help that assign your health effect ratings. You can look at the HMIS health code and the PA health code. I would say nothing's perfect, but those are great references that you can use as a reference. People use bands that are based on the OEL numbers. So if the OEL is between 0.01 and 1, it's a this. If it's between 1 and 10, it's a that. So you can band it by strictly what the OEL numbers are. Some people go into it and use occupational exposure bands or hazard banding. NIOSH has got a great resource on that. I strongly encourage you. There's a lot of details in there, a lot more than I got time to get into it here, but they got a really good technical report on that. So definitely, if you have time, download that. And another option is that you just use your best guess based on the AHA's definitions, which is the blue in the upper right-hand corner. One is reversible health effects, a very light solvent, versus something that is a 4, that is a life-threatening, a disability, injury, or illness. So these health effect ratings, once again, decide and document what you are. In an ideal world, you take all of your stressors and you assign a company level health effect rating to them. In that way, that takes, one of the 50% of your ratings will be standardized. Then you only got to worry about making sure that your health effect ratings are pretty consistent across the company. This is where I would ask if there's any questions, but this is a webinar, so I'm going to keep moving forward. So how do we perform? So I've done all of my ratings. I've got all my stressors out there. I've got my health effect ratings assigned to them. What's the outcome? This is where we take the seg table that we had before, and now we break it up for each individual stressor. So for example, the first 2 lines are Elke unit operators for their full shift, but now I'm separating it, doing an exposure risk profile for hydrofluoric acid and for noise. And I select the appropriate exposure ratings for those, the appropriate health effect ratings, and then the risk rating is just a simple multiplication. So 1 times 3 is 3, 3 times 3 is 9, and that's basically how you go out and do your actual assessments. It's pretty simple stuff. At the end of the day, this is my deliverable. So when the assessments are done and completed, I put them into a simple risk matrix. And this is just a count of all of your SAGs, stressor combinations, and where they reside. This provides a really concise, consistent presentation of what your current risks are. Really what it does is it explains to management and workers, hey, this is what IH does. We are like safety, except for it's not abrasions and short-term acute type, typically acute exposures or injuries. We're dealing with more typically long-term, adverse health effects. And once that light bulb goes off and they get it, they understand hygiene a lot more. Really quick story. I worked for a company down in Houston, a big oil and gas company, and I had 32 marketing terminals around the country that I had to go out and do quote unquote industrial hygiene for. And I was 23, 24-year-old kid, and I'm like, you know what? How do I go out and do all 32 terminals around the country? And I looked at what other people did, and it was the typical go out and monitor, and you write a report and you file it. And I'm like, there's got to be a better way. And then I remembered, you know what, that guy from Dow, he wrote a book, I think with AIHA. So I pulled that out because that was the only version, was version 1 of the exposure assessment strategy book. So I pulled that out and I read it. I'm like, this is how I'm going to do it. So I did it old school using Excel. There's a lot more work than what software can do for you these days. But I came up with this risk matrix just like this, presented it to management. And, this guy, good old Texan boy, leaned back in his chair, put his cowboy boots on the desk. He says, I've been paying for you boys for 30 years. He goes, I finally understand what it is the heck you guys do. And I got his attention. And not only that, but he looked at that number 1 in the red and said, hey, what's that red there? I don't like reds. Get rid of that red. And now I had his attention, and we talked about controls. And really, I was able to justify a control that I put in probably 7 reports earlier that were never read. And they just filed them and said, yep, industrial hygiene, give me a report. Yep, they did their report. That's great. So using the matrix really helps open that door. It really just helps if they understand what you're doing and you're presenting it and they're asking questions, then you got their attention. So the third step is sampling plans. And this is where I wish we were in a live audience, because there's a lot of discussion every time I cover sampling plans here. But how do you decide what to sample? Number 1, you got to decide, is there any regulatory requirement? Do I need to monitor for noise in my mine, noise and dust every quarter? Do I need to do it? What's required by standard, number 1. And then what most people do is they tend to be more reactive. So, there's sampling that is requested by management or requested by employees. Or if they don't have that, or a lot of those, they just say, you know what, or especially when you have somebody taking over an IH program that was a pretty good IH program and they retired or moved on, and you're coming in as a non-IH professional, and they're like, hey, you know what, Mary did a great job for 20 years. Let's just repeat what Mary did for the last 20 years, and let's just do the same sampling. So now you're repeating sampling for very little benefit. And this is something I learned at that oil and gas company. My supervisor came to me. He goes, oh, so you're going to the refinery to help them out? I'm like, yeah. He goes, let me guess, you're going to do some benzene, some BTEX monitoring, some noise dosimetry? I'm like, yeah. He goes, well, do you think we have any data on that? And I'm like, well, I'm sure we do. He's like, yeah, we got like 40 years of data on that. Why are we continuing to do that? So it really opened up my mind to say, that's a great point. If we have data showing this is the risk level, why do I need to keep collecting more and more data? So the key question that we need to ask ourselves is, where do I need more data to know what the true exposure risk is? If I know what the exposure risk is, what's sampling going to do? I mean, there's very little benefit. You're just validating, yep, things are still the same. There's still a high noise exposure. Okay, so the deliverable at the end of the day is setting up your sampling plan. And your sampling plan, you basically lay out your segs, and then you define, is it a personal area, wipe samples for benzene? What are the stressors? Typically, it's all personal samples, but you might identify if there's some area or wipe samples. build this out here. Sorry about that. The first thing that you want to look at is your uncertainty rating. So there is a rating that we use in our software that really makes it simple. If I give it a rating of certain, meaning I've got tons of data on this, it gives a rating of 0. If I don't have a lot of data, I have some data, I'm not 100% certain, or I'll call it uncertain, that gives a rating of a 1. And then if I'm just guessing, it's totally professional judgment. I have no data on this, and I'm just swagging it. I'm going to give it a highly uncertain, and that gives it a rating of a 2. And what that does is that basically what you do is you take your risk rating times your uncertainty rating, and that gives you what's called an info gathering priority rating. Essentially what that is you're just going out and you're going to sort by the info gathering ratings to see the highest levels of importance, I'll call it. And I'm going to start with those on my sampling plans. All the ones that are zeros, what we're saying is that regardless of the risk, I might have high exposures to benzene or noise or whatever the case may be. I got tons of documentation on it. I don't need to go out and monitor it because I know what the exposure is. So the ultimate goal is to have zeros up and down the info gathering priority rating, and you're good. If you don't have all zeros, then you go to the highest ones and you focus those and you roll those over into your deliverable, which is your actual sampling plan. Okay, so you lay out and say, here's the number of samples I'm going to take. Here's a scheduled completion date, and that scheduled completion date might be per quarter if you do quarterly monitoring, or you might assign it for certain times of the year that have higher exposures, or if it's random, then you would put it in for December 31st. Then you would track where you're at versus plan on each individual line item, and you can calculate the percent complete on that. And then you can, for a overall site, you can roll up all those numbers and say, okay, I've taken 6 of 24 samples, therefore I'm 25% of the annual site plan has been completed. And that's really beneficial for if you're using consultants. I could put together this table, copy it, send it off to 3 consultants and say, here's your scope of work, give me a price. And then, as you select your consultant and they start working, now I can start to track where they're at versus plan. So a lot of companies are using consultants. This is a great way to help develop a really clean, tight scope of work and manage the consultant's status. Okay, let's talk about lab analysis. So labs it's often overlooked, to be blunt. Labs can be a great partner. They can help your IH program and make your day-to-day work a whole lot easier. So the first thing you need to do is select a laboratory, and the only must that I would put in here is I would definitely make sure that they are a accredited laboratory. Is it AIHA accreditation? Is it EM Lab? Whatever the accreditations you need to define those. And if they're in a third world country and there's no AIHA laboratories, but it's a volatile and you got to get analyzed there locally, whatever the case may be, get the best you can get and document it. We have had situations where the labs weren't accredited, but they were the only option. Then you need to look at the labs. Can you use, or do you want to use a local lab, or can you use one of those big companies that you might be able to get a smaller price on? So if I've got 40 locations around the world and all of the sampling I do can be shipped to one central laboratory here in the US, and I can get a corporate discount for it, and they're accredited and they got CIHs on staff, and it's just a great laboratory, that's great. You might be in a scenario where it's a very volatile or very something that you need the analysis turned around in 24 hours. So you might need to find a lab that's local. So a lot of our customers actually have local and they use them when they need to, but they also use, the larger laboratories and try to get discounts because they're sending them so much work. Having a CIH, a lot of labs now have CIHs on staff. Great resource. If you're a CIH, it's just a great sounding board. If you're a non IH professional and you're just looking for help, hey, I'm looking to monitor for this. I have no idea what to monitor. Help me out. That's what they're there for. Some labs have the equipment loan, free pump loan programs, things like that. Really good if the pumps are quality. I've heard horror stories, and I've heard, but by far the majority of people that are using these like them. But I've heard horror stories where the pumps come, and they were at, a Coke plant the week before at a steel mill, and they're beaten up and full of dust, and they can't hold a charge, and yada yada yada. One of the most important things, though, as you all can appreciate, is customer service. Having that laboratory that's got your back, somebody that can, understand what issues, everybody has issues. How they deal with the issues is something that you really need to take a strong consideration when you find your laboratory. Are they willing to work with you? If they make a mistake, will they, fess up for it and do what's right to make everything right? And then the next two items, does the laboratory have an online sampling guide? Do they have an online chain of custody form you can fill out? If you've got a software database that you have, can you interface that system with the laboratory and get the data in? I'll explain more on these next two items, these next couple slides here. So just as an example, Golliston's got this, really nice sampling analytical guide information online. It's really slick. I can query up and say, oh, BTEX has done two different methods. Here's the two methods. Which one do you want to use? And you can select which one it is, and you can assign it on your chain of custody. A better way of doing that is if you have software, for example, ours, where we're integrated with the laboratories. So we actually have all of their catalogs for all the major laboratories are linked in with and tied with our system. So as you select the laboratory, it says, oh, you want Golliston? Well, here's their catalogs. And now I can, within my IH database, select exactly the analysis that I need to have done based on the laboratory's content that they push into our system. So here I select BTEX, I hit save, it says, oh, okay, it's the NIOSH 1501 method, and all that table down at the bottom is their sampling analytical guide information that you also see on their website, but you don't need to go to their website because we present it to you right here. And then at the end of the day, you're tired, 10-hour shift, you got to post-calibrate all your pumps, collect all your media, and you got to fill out that stinking chain of custody form. Time consuming, it's an extra half an hour in your day, writing it all up, packaging it all up. You should get with a vendor that works with a software vendor, or a laboratory that works with a software vendor that can generate the chain of custody directly. So a click of a button, it knows the laboratory, it's got all the information, it's got all the information you need for the chain of custody. You print it off, you ship it to the lab, and you're off going home. So instead of, an hour, 40 minutes to fill it out by hand, you can click, 5 minutes later, you're out the door. And then when the results come back in, now I can go back and review the results. So all my analytical results come to me. I look at the mass and concentration. If that data looks good, I click on the accept button, and all of that data gets loaded for me. So I'm not having to manually enter in every single result. Huge time saver. And most IH databases have this. Work with a system that has it turnkey. For instance, since we're integrated with all of our laboratories, getting a lab interface up and working is literally about 20 seconds. We punch in a code, you're integrated. We have a full chemical and OEL database that's linked in, and the setting up of your laboratory interface is done. So that might be available with others by all means, but make sure that you understand that process, Because if it is very manual, then you need to have more administrative support of your software, and it becomes more of a nightmare. Yeah. So let's talk about data analysis. This is a process that uh, uh, it has its own, the way that I look at it personally, is it has its own 5-step process. For example, start at the very top. I'm going to define my goals. One goal I might have, say, you know what, I want to protect the workers from health effects, from coming down with cancer when they're exposed to benzene, right? That might be my ultimate goal. And then the questions I have to meet that goal is, well, which segs have a high potential for exceeding the action level or the OEL, whatever the question might be. Then you go to the next level and say, okay, that's the question. How do I answer that question? I'm going to answer that question by defining my tools. So I'm going to use the IH stat tool, and I'm going to look at the 95th percentile or the 95 UTL. So what tool am I going to use to analyze that data, and what stat am I going to use? Then I go off and do the analysis part. Whoop, sorry about that. And the analysis part is I'm going to go out and collect all the samples, and I'm going to run the stats based on the tools and the stat that I defined in the previous step. I look at the data, I look at the 95th percentile, and do the analysis. It's very simple if you go from the start, work yourself from left to right. And then once you look at that data, what action needs to be taken? Is it a control measure, or is there no issue because you know what, we're below the analysis that I did was using those tools, answered the question, and the answer was they're not exposed to a significant level. Therefore, I'm meeting my goal. Way too often we jump into stats. So when you think of data analysis, most of us immediately think of, hey, this is great, stats. Let's dive into some stats. Let's do some stats. Stats are great. And it's just a number. The numbers don't mean anything unless you know what you're expecting. People use iStat, Hygienist, BW Stat tool, Paul Hewitt's EAS Bayesian tool, all great tools, fantastic tools. But which tool do you need to use to answer what question? So let's talk about how to really do a data analysis. Once again, start off at your goals. Is my goal to look at my segs and confirm that they're actually similar or homogeneous? For you folks that have been around a while, that term homogeneous. Looking at exposure ratings. So maybe you might have some analysis looking at all of your data to confirm that the exposure rating you pick during your qualitative exposure assessment is the appropriate one, like using your Bayesian tool. Compliance. It could be a simple, are we in compliance or not out of compliance? Do we have overexposures exceeding the action level? Looking at medical surveillance. Control verifications done all the time. We've instituted this control. Does it work? Well, that's a simple question, but what does it work at what level? So if it's a high potency thing, and I got a fully enclosed closed procedure or manufacturing process, I shouldn't detect anything. Versus, yeah, we stuck some general ventilation to push the dust to the far corner of the room, or local exhaust ventilation, where you still get some level of detection, maybe, but what's the right level, right? So you need to determine that before you actually go out and do your monitoring. And then, or are you identifying, those segs for your medical surveillance plans? So show me all the people that exceed a threshold for X, noise, benzene, whatever the case may be. The next thing is you need to determine the method. What's the best method for each assessment? And I'll walk you through some examples of that. And then you perform your analysis. So after you perform the analysis, can you take action? Is there insufficient data, meaning the data is sporadic, it's all over the place, standard deviation is 6, it's not consistent, all over the place, or does it identify where additional sampling is needed? So a very simple method for this. Um, if you ask the question, hey, I want to confirm my segs are truly segs, you can literally just, you can't go out and do a, analysis of variance tests, ANOVAs, and there's a bunch of machine learning type things that are out there that you can look at clusters and everything else, or you can just take the old school and say, you know what, I'm just going to use a scatter diagram, give me all the benzene exposures for this seg, and I'm going to throw it up there and look at the data. And you can see 3 distinct clusters in there. The one on the left, you're looking at sample duration. So those are all stealth samples. Let's assume it's for the same task. That's pretty tight. I think I'm good with that. Wow, my full shift exposures are different. When they go to about 480 minutes, so an 8-hour shift, I've got 2 clusters of exposure concentrations in there. Why are they different? And that's, so at a really quick, using a quick and dirty method, I can determine, oh, looks like there's 2 clusters here. I can look at the paint booth example and say, okay, the one with the higher exposure up top, that's the old paint booth with no ventilation. The one down low is the one with the very good ventilation. It might be, if you're looking at dust exposures in a mine, a surface mine, and I've got the positive pressure cabs, it could be a really old cab. The seals aren't in good shape, or they're not even there. The fan's been broken for a year, 2 years, 10 years, and the inside of the cab's full of dust, versus a brand new cab, which has got positive pressure seals tight, fans working, filters are working. That's where you dive into the individual points. Another method is looking at your stats. So if you look at the IHStat tool, which is the screenshot on the right, that's a free tool. You can just Google it, IHSTAT, IHStat, and it's freeware, so you can download it, and it's a really handy tool. But you need to determine what exactly are the factors. So here, I'm going to say geometric standard deviation of less than 3 is a good indicator that my segs are homogeneous. I'm going to punch in all my numbers and look at my geometric standard deviation. In this example, I'm at 2.03, which is the blue arrow pointing to the GSD. So at 2, I'm less than 3. I meet the criteria. It's homogeneous or similar, and that seg is in good shape. This stuff is analysis tools. This is not for presentations. So I've seen many people do this. They actually pull this up and say, well, geometric standard deviation less than 3. So, people don't care about that. These are tools for you guys and gals, not for presentation. So for data analysis, once again, we need to look and ask ourselves, why are we doing the analysis? We need to take the time to think through these 5 steps. So when we get the numbers mean something. And I'm expecting a number between greater than this or less than that, or I expect it to be around here, or whatever those 5 steps tell you, or 4 out of 5 steps tell you. When you get that number, you should know what that number means. Okay, let's briefly cover medical surveillance. And medical surveillance is basically where you're taking your segs and you're going to say, you know what, let's look at exposures of noise. And the operators at the Coker unit on the right-hand side, they don't have any high noise exposures above 85 decibels. But the operators at the reformer unit and our maintenance techs do. So I'm going to take those 2 segs and enroll them in a hearing conservation program. And how do you establish your medical surveillance programs? Number one, you have to look at and say, well, what surveillance programs are in my workplace? What are the stressors, and what are their thresholds? And do I have SEGs that exceed those thresholds? All of those details. You can take a look at this OSHA guide, really handy guide. It lists all of the medical OSHA medical required surveillance programs that they have. They list the thresholds. They list a lot of really good details, so it's a really good resource. But for an example, I talked about the two SEGs that are exposed to noise. I can define my threshold at 85 dBA, and I can say these are the two SEGs that are in that threshold. So now the SEGs go in, and because I have people assigned to SEGs, those people automatically get enrolled in those surveillance programs. So the hardest part with medical surveillance programs is not identifying the programs. It's not identifying the thresholds. That's pretty cut and dry. The hard part is if I identify, here's the 4, 5, 6, 10 SEGs that are in that surveillance program, it's doing the worker tracking of who's current in those SEGs. So if I got a person that was in SEG 1 and they move out of it into a different SEG that's not in this medical surveillance program, well, they need to be de-enrolled and removed from that surveillance program. And that's kind of the biggest challenge is maintaining that worker tracking per SEG. And the ultimate goal is that we have compliance without over testing the workers. We are going to make sure that we're in compliance. So we're testing the people that need to be tested, but we're also removing people that don't need to be tested. And if we remove the people that don't need to be tested, number one, there's hard cost savings. So if it's $200 per audiogram, and the time it takes, and I've got 10 people, that's $2,000 I'm saving the company. Not a huge savings, but it is a savings. The bigger savings come when you have people that are not supposed to be in the program, so they're not overexposed to noise above a threshold, but they're also hunters, they're drummers in a rock and roll band, and you're also testing them. That's when you're taking on a lot more liability, a lot more cost. So let's jump to the last piece, and I want to make sure I got to this. I'll try to leave at least 5 to 7 minutes for Q&A, so please enter in your questions, and Kay will read those to me. But the most important thing I really wanted to get to here is how do we evaluate and communicate performance of an IH program? So if I was to ask you guys, what is the status of your IH program? How do you answer that? If I was to ask a business owner or a finance person, it's really clear. Oh, our EBITDA is this. Our year-to-year revenues increased 10%. If I asked the safety person would say, yeah, we've had 100 days without any OSHA recordable incident. Our incident rate is 1.2, so we're down 25% from last year. If I ask a risk manager, yeah, our mod rate is X, 1.2, knowing that 1 is average. So there's clear metrics in that. But when we get to industrial hygiene, most of us don't know how to answer this. And the way that I would recommend that we look at the status of our IH program, sure, there's metrics, sure, there's straight numbers, and we can develop those KPIs. But how do you get to those KPIs? I would look at it as say, how precise are you with your risk assessment? So on the left-hand side, I'm looking at, I've got ratings 2, 3, I got 2 SEGs here, 3 SEGs there. Are those accurate? Are you 100% convinced that that's where the risk is? So on the image on the right-hand side is think of like a scatter, what do they call it? Shotgun approach. So I'm taking a Y stab, and in 2018, I think that this is probably the level of precision, and I identify those items in my sampling plan that I need to monitor to get more precise. So in 2019, I'm more precise, but I'm not quite there yet. I take some more samples of what I need to. So each year I become more and more precise on my qualitative risk assessments. So how do we get more precise? And think of this as a IH work versus communication tools. So the left-hand side, 3, and I can't define that color. It's like a light orange, yellow. Those are things that you work with, that we work with as hygienists. So we're going to do all the IH monitoring or direct reading, the lab analysis, the data analysis of all the data, and that's going to help us, fine tune our qualitative exposure assessments. That's all stuff that we do. They don't need to know all, how we make the sausage, right? You go to the blue items. This is where we start communicating with workers and management. We show the risk matrix. We show the analysis of controls and medical surveillance programs. So basically, hey, based on a risk matrix, here's the medical surveillance programs. Maybe here's some KPIs of the number of people in hearing conservation, number of people out here, the cost of those things. So now you're presenting management type data to them that matters because it's the almighty buck. And then you put together a sampling plan that says, hey, because of the risk matrix not being 100% sure, and we're putting in some new controls, here's the monitoring that we're setting up for next year. And management looks at that and says, yeah, totally justified. Here's your budget. If you present that to workers, they're going to look at that and say, oh, I got it. So I'm wearing this pump because we installed this new control. So we're just verifying that it works. Got it. Makes total sense. So the more you communicate with them, the better the better they're going to feel about wearing it, because they're going to understand why they're wearing that pump all day. They're not going to mess with their media, hopefully, as much. So how do we communicate with workers and management more? We need to move from less documentation. So right now we document. We got datas with all of our sampling data posted in the work area. We do employee notification letters. We do IH paper reports that get filed and shipped off to a salt mine in 5 years. Move from that. Still, we need to document, and that's fine. But we need to do on top of that a better way of communicating, using graphical presentations, risk matrix, aka jump on the bandwagon. Whatever works for safety or quality or environmental. If they're getting their points across, what tools are they using? Ergonomics does a great job with Kaizen. Look at that. Engage and collaborate on what control methods. You might think it's ventilation because you had a lot of classes in ventilation. That's what we want to use. That might not be the best answer. Get with the people that are on the job, doing the job, to help you look at it. And again, this is, so if I presented this risk matrix to a manager, they're going to look at the red and go, whoa, 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 I don't like reds. Get rid of the reds. How do I get rid of the reds? And you're like, hey, no problem. We're going to get rid of the reds. So that's how it's going to look. But that's going to cost you these controls. And here's the cost. And here's, everything with controls. Management hates reds. So if you present it this way, you're going to get their attention. Now you can talk about, here's my recommendations for controls. And such as, when you present options, don't present one, because if you present them with one option, their only response could be yes or no. If I response them with multiple options, then you start the discussion of which option is best. Huge differentiator. The data that management wants to see: how much does it cost me? What's my return on investment? What's my break even? So if this thing costs me $100,000, but I'm saving $20,000 a year, okay, 5 years is my break even. So I'll pay for this thing in 5 years, and every year after that, I save money? Yes, okay, great. Might not be the number they're looking for, but at least you've given them the information they need to make the analysis. And the other piece is the level of effectiveness and impact on production. If you're with a high potency material, such as a pharmaceutical plant, recommending a closed system is millions of dollars, very expensive. But if you go to them and say, hey, look, we're going to be able to recapture all that lost material, aka pharmaceuticals, and we lose, $3 million in pharmaceutical dust, and we're going to recapture that, and it's going to cost us $1,000. That's a 300% return on your investment, and infinite returns every year afterwards. Why wouldn't you do that? So I'm going to skip past the summary because we're running low on time and jump right into the questions. Kay, do we have some questions there?
Okay, thanks, Dave. It looks like we have about 3 or 4 minutes left for questions. Just a reminder, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send it to all panelists. The first question I have, Dave, is how do you obtain an exposure rating for a qualitative assessment prior to personnel monitoring / sampling?
An exposure rating? So that's truly your professional judgment. You could use direct reading instruments. You can look at previous data for similar operations. And if you don't know, then you take your best guess, rate it as a highly uncertain rating, and then that will help you drive out that that's something you need to monitor afterwards.
Okay, great. I think this is a related question to that one. How would you determine the percentage of the OEL for the exposure rating?
Yeah, it's the same type of question. You have to determine what the OEL is, and then you're taking your best guess. You could call up anyone else in the industry. Networking's a big thing. But if you don't have a clue what it is, that's a good thing to know. It's not bad to say, I don't know what that is, because this way you document it, and you're documenting it as a highly uncertain. And if you're guessing it's a high exposure, if you smell a lot of vapor in the area and it's benzene or some toluene or whatever the case may be, and like, holy crap, it burns my eyes. Okay, find the right PPE until you get data.
Okay, great. The next question I have is, what was Kaizen? I think you mentioned it a couple slides ago.
So Kaizen is I think it comes from Japan. Toyota's really big on it. So you can query Kaizen, Toyota, ergonomics. I know our human tech partners in our company within Velocity EHS, they use it a lot. And really what it is it's if you go to a lot of manufacturing plants, you can see how the workers modify their tools to work a lot better than what's given to them. And that, they know the business better than we do. So if you work with them and say, hey, here's an issue, I'm thinking of this, what do you think? I think we can control it this way, or can modify your workspace this way. And they might laugh at you and say, oh no, because I'll bump my head over here on this cross beam and I can't bend over that. You might be bringing in worse scenarios when you're trying to do the right thing. They know their workplace better than you can possibly. And if you work with them and design something with their input, you're going to be a lot better off.
Okay, great. Thanks, Dave. Unfortunately, that's all the time we have for today. I just wanted to let everyone know that if there are any questions that we didn't get to, that we will be passing those along to Velocity EHS. I wanted to thank Dave Reese for his presentation and Velocity EHS for sponsoring today's webinar. And to all of our participants, thank you for coming. Registration is already open for another Synergist webinar coming up later this month. On October 29th, please join us for Cloud-Connected Sensor Networks and Building Reopening in 2021, a Synergist webinar sponsored by SGS Gulfin. Thanks to everyone again, and have a great day.
Thanks, Kay. Thank you, AIHA, for hosting this event. And wish we had more time for questions, but yeah, I'll get a list of those questions and make sure that we respond to each and every one. Thanks for all your time.
All right, everyone. Thank you so much. This actually concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts.